Welcome, ladies and gentlemen, to the technical forum at the group exhibit Hydrogen Fuel Cells and Batteries here at the Hannover Fair 2018. I invite you to sit down here, order a drink and enjoy the next presentation. Our speaker will be Mr. Takaishi now, the president from Takaishi Industry, and his presentation will be on the O-ring materials for hydrogen stations devices. Please welcome with me Mr. Takaishi.
Thank you. Thank you for the introduction. So, welcome, everybody. Thank you for coming and taking time for my presentation. My name is Hideyuki Takaishi from Takaishi Industry, Japan. And today's my theme is introducing O-ring materials, our materials for hydrogen station devices. So let's go. As you know, there is many applications for hydrogen stations to refueling FCV, like what to do that? No. Pointing here. Breakaway nozzle, breakaway valve regulator, and the tank compressor or electrolyzer or something. There are so many gaskets O-rings will be used, like a joint fitting valves or something. And first, I want to focus on the breakaway device. This is, I think you know, this is the for the safety device for refueling to SCV. And required specification condition of the breakaway devices is very tough. Hydrogen charging time is less than 3 minutes, and the pressure range is 0 to 70 megapascal, and the temperature is minus 40 degrees to 85 degrees. This is what we call pre-cool T40. This condition is very, very tough for rubber material to seal. So usually O-ring will be break like this. Normal O-ring, yes, with high pressure hydrogen. Hydrogen penetrate into the rubber O-rings. This is cross section, and when decompress the pressure, hydrogen inside will explode like a bubble, and this will be this makes a crack. And this is the reason of the leaking. And one more fracture, what we call overflow fracture, with penetrating hydrogen, there will be a volume increase of rubber O-rings, sealings, and the sealing will overflow from the groove. That will lead also fracture. And one more, with low temperature, we will have a facial leak. With low temperature, the rubber material will be frozen, like frozen, and it will lose the flexibility. For that reason, with high pressure, like a lead arrow, hydrogen will be easily to leak. We have solved this kind of issue, and we made a solution. We made a solution with associating academia. This is what we call Hydrogenius. It's from Kyushu University. It's western part of Japan. There is a Kyushu University. This university is very, very famous for researching for hydrogen research. And there's a polymer team leader, Professor Shin Nishimura, and we collaborated with him and made the best recipe. For example, to improve low temperature, we made this kind of table and this kind of experiment, what we call orthogonal array experiment. It's a statistic method. With this, we found a solution. What is the best mix? What is the effective factor? And we made this number 4, 5, 6, the green one. It's very good for minus 40 to plus 85, both good. And this is the cross section of the picture. And the middle line, green one, polymer BB base, it's no leaking. And the others, the left and the right, there will be another mix, but they have a crack and leaking. So we made an endurance test, duration test, cycling duration test with collaborating with test institutions. It's in Kyushu, not the university. It's Fukuoka Prefecture in Kyushu, what we call High-Tech Hydrogen Test and Research Center. And with in this facility, we made 6,600 times cycling test with 0.6 megapascal to 90 megapascal, 900 bar. And we made in the minus 40 degree hydrogen, we made many 6,600 times cycling test, and still no leaking. It's no problem. And that's why in Japan, our O-rings, that kind of O-rings, is now used in a hydrogen station, commercialized station. It's near Tokyo Tower, and this is the busiest station in Japan. Maybe in average, we have 15 cars per day, and it's working. It's very nice. And we are now I'm talking about the hydrogen station, breakaway devices. But as you know, as I explained, there's many devices and many fitting joints or something, and in there, by the devices, the temperature range is different. For dispenser, it's a pre-cool minus 40 to 85 degrees, and for the tank, cylinder tank, it's like normally it's used in ambient temperature. And for a compressor, it's going to be high temperature. So material will be changed, needed to change. So low temperature and ambient temperature, EPDM is very good. And for high temperature, FKM will be great. So we focus on the next step as FKM. So yeah, this will be used to compressor. And yeah, we made a best mix again. We find a solution, best mix again, and we put it into a duration test, cycling test. So you see the left line and the right line. We made a FKM compound, FKM recipe, and they can bear to up to 150 degrees or 180 degrees. While the center line, there's for comparison, we made put a test FFKM. It's a very good performance for medicals, but for high pressure hydrogen and high temperature test, the FFKM have broad blister and crack, and it leaked. So we made a solution about the high temperature. So this is summary. The temperature range of the hydrogen station devices are different by the devices. So it's needed to make a special compound. So we need a best mix to seal them. And the O-ring of hydrogen resistant EPDM can be used. It's our special one, from minus 40 degrees up to 85 degrees. And the O-ring of the hydrogen resistant FKM for high temperature can be used up to 180 degrees. And now we are on we have booths. 3 companies from Japan are now exhibiting together. And one more information. Today, we have Japan night. From the 4:30 to C56, hall 27, our booth. We have sake, sushi, and we are serving Japanese snacks. So let's join us. keeping we enjoy our Japanese night. Thank you so much. This is the end of this presentation. Thanks so much.
Thank you very much for this super presentation, and thank you also so much for this kind invitation to the Japan night today. Now we have still some minutes left for questions from the audience. Is there anyone who wants to join?
To Japan night?
Okay, so it seems that with your O-ring, the need of changing this old material decreases now. So how long do you think your new O-ring can stay inside the plant until it has to be replaced?
In my test, it's supposed to be duration is 1 year, because we have annual inspection by law for hydrogen station. So we made a test simulating 1 year refueling, and we multiplied safety ratio 3 by 3. So we made 6,600 times. Means 1 year refueling is 2,200 times in our calculation, and multiplied 3, it means 6,600.
Okay, thank you very much.
Yeah, you're welcome. My pleasure. Thank you so much.
Okay, and thank you in the audience for joining us here. Yeah, he already told for any further questions, you can find Mr. Takaishi at booth number C56. Yes. Thanks. Yeah. Now, the next presentation will be on thermal hydrogen compressors that have already entered the market. See you there.
Thanks so much. My pleasure.